Hey, welcome back. Today we're going to be talking about how to solve force as the derivative of momentum style problems, or using the fact that force is the derivative of momentum. How do you solve problems related to that? How do you justify it? How do you think about it? And this is primarily for AP Physics C mechanics students or similar students in university classes. Alright, so let's go ahead and get to it. First of all, let's think about a net force. So a net force is equal to mass times acceleration. We already know that. But we've learned lately that we can sub in dv dt for acceleration because that's what it is. The derivative of velocity with respect to time is acceleration. So let's think about what that would mean. So our net force is equal to mass times dv dt. Now if we assume a constant mass, which is the case in most cases. Most problems we're going to be dealing with are going to have a constant mass, so that makes sense. Assume a constant mass, then we can say the net force is equal to the derivative of momentum with respect to time, because this mdv with respect to dt is the derivative of momentum with respect to time. So I'm going to write that. And so that's how you could justify it. That's how you can think about this. I want to talk about a related idea before we move on. Before I show you an example problem, we're going to say just as acceleration is related to velocity, so momentum is related to force. Alright, so let's go about using this in a example problem and see how this goes. Okay, and so looking at how to solve one of these problems, let's take a look at a problem, and honestly I don't remember if this was originally through the College Board or just a related problem, but let's give it a shot. So it says the momentum p of a moving object as a function of time t is given by the expression of this function, where k is a constant. Write an expression for the force causing this motion. Alright, so what we're going to do is just differentiate. We're going to say force is the derivative of momentum with respect to time, so we can take that derivative. Our n value is 3, so we're going to reduce that by 1, bring the 3 out in front, and this becomes a 2. And that's effectively what you would have. You now have your function, and if you had the specific value of time, you could plug it in and solve for the instantaneous force at that time. That would be an additional thing you could do with this if the problem asked that of you. In any case, I do want to say I've done screencasts and lessons on an entire year of physics, as well as most of the ideas for an AP Physics C mechanics class. If you have any questions or comments down below, please let me know, and I hope you all have a great day. Take care.